Let us now check another example on how to use the method of Lagrange multipliers. We're asked to use Lagrange multipliers to find the maximum and minimum values of the function f of x comma y equals to 2x squared plus 3y squared minus 4x minus 5, subject to the constraint x squared plus y squared is less or equal to 16. First of all, we'll need to find whether we have any critical points. And to do that, we'll have to check whether the gradient of f is equal to the zero vector. So we'll have that fx is of x comma y is equal to 4x minus 4. And setting that fx to be equal to 0, that will give us that 4x minus 4 is equal to 0, which means that 4x is equal to 4. So that means that x is equal to 1. Let's check what happens with the fy. And in this case, the fy of x comma y will be equal to just 6x. So setting fy to be equal to 0 will give that 6y is equal to 0, which means that y is equal to 0. So the point 1, 0 is the only critical point. Of the function f, and it lies on the region x squared plus y squared is less than 16. So it lies on that region. And so we'll find what is the value of the function at that point 1, 0, which would be equal to 2 times 1 to the square plus 3 times 0 to the square minus 4 times 1 minus 5. So this is equal to 2 minus 4 minus 5, which equals to 7. So the value of the function f at the point 1, 0 is equal to -7. And we'll keep that to compare when we find what happens to the function f at by also using the method of Lagrange multipliers. So on the boundary of the constraint, so on the boundary, we have that g of x comma y is equal to x squared plus y squared is equal to 16. So we're only checking the boundary of the function of the constraint that we have. And in this case, if we find the gx of x comma y, that is equal to just 2x, and gy of x comma y is equal to 2y. Now, we'll try to find the three equations from which we'll evaluate the x, y, and lambda. So the first is that fx should be equal to lambda times gx, and substituting, we'll have fx is equal to 4x minus 4, and this is equal to lambda times gx, which is equal to 2x. And then the second one is fy is equal to lambda times gy. So that means that fy, which is 6y, is equal to lambda times gy, which is again equal to 2y. And then the third equation is the constraint. So we'll have that x squared plus y squared is equal to 16. Now, let's check the second equation. Let's start from the second equation to see what we can find. First of all, we have that 6y equals to lambda times 2y, and that means that 2 lambda y minus 6y is equal to 0. And that gives that 2y, if we factor 2y, we'll have lambda minus 3 inside the parentheses is equal to 0. So that gives us two solutions, either that 2y is equal to 0, so y is equal to 0, or that lambda is equal to 3. So we'll use these two solutions to plug them into the other two equations to find what in which points we have minimum and maximum values for the function f. So first of all, if y is equal to 0, from equation 3, we'll have that x squared plus 0 to the square is equal to 16. So that means that x squared is equal to 16. And that means that x is equal to plus or minus 4. So that gives us 2 points, the point with x equals to 4 and y equals to 0, and the point with x equals to negative 4 and the y is equal to 0. And let's check what happens to the function f at 4, 0, which would be equal to, so we just go and plug in 4 for x and 0 for y in the actual function that we were given. So that will give us 2 times 4 to the square minus 4 times 4, and then minus 5, which is equal to 32 minus 16 minus 5, and this is equal to 11. So the f of 4, 0 is equal to 11. And we also have to find the value of the function f at negative 4, 0, which would be 2 times negative 4 to the square minus 4 times negative 4 minus 5. So this is equal to 32 plus 16 minus 5. So this is equal to 43. So f of negative 4, 0 is equal to 43. So we'll keep those two values to compare at the end after we find all of the points that are candidates for minimum and all the points that are candidates for the function to have minimum and maximum values. Now we checked that y is equal to 0, what happens when y is equal to 0, and now we'll check what happens when lambda is equal to 3. So if lambda is equal to 3, from equation 1, we'll have that 4x minus 4, we just plug in lambda is equal to 3 to this equation, and we'll have 4x minus 4 is equal to 3 times 2x. So that gives us 6x minus 4x plus 4 is equal to 0, which means that 2x plus 4 is equal to 0, and that means that x is equal to negative 2. We have now to find the corresponding value for y when x is equal to negative 2, so we'll plug that x equals to negative 2 to the equation 3. So we'll have negative 2 to the square plus y to the square is equal to 16. So that will give us y to the square is equal to 16 minus 4. So that gives us that y squared is equal to 12. And that gives us that y is equal to plus or minus square root of 12. And this is equal to plus or minus 2 square root of 3. So we have another 2 points that we need to check the value of the function f. So we'll have the points negative 2 and plus 2 square root of 3, and negative 2 and negative 2 square root of 3. And plugging the value, these points on the function f will have that the f of -2, 2 square root of 3 is actually equal to the value of the function f at the point -2, -2 square root of 3. And this is equal to 2 times -2 to the square plus 3 times either plus or minus 2 square root of 3 to the square for the y, and then minus 4 times -2 minus 5. So that will give us 8 plus 36 plus 8 minus 5, which is equal to 47. So the value of the function f at the point -2, 2 square root of 3 is equal to the value of the function f at the point -2, -2 square root of 3, and it is equal to 47. And we now need to compare this value that we have found by checking the critical points and also using the Lagrange multipliers. So we see that here we have this value of the function 47, which is actually, if we check these different values, this one, this one, this one, and this one, we see that this is the maximum value of the function f. So the 47 is the maximum value of the function f. And also checking the 47, 43, 11, and -7, we see that -7 is actually the minimum value of the function f. So let's write that here. So the value of f at the point 1, 0, which is equal to -7, is the minimum value of the function f.